Welcome to Image Processing with ArcGIS Pro. 12 YouTube videos summarize image processing lab exercises available in a step-by-step lab manual that accompanies this textbook. Download the lab manuals at the site shown and obtain more textbook information at the second site shown publisher's website. Download the lab manual and data used in the lab exercises if you want to use the step-by-step instructions and process the imagery and DEMs while viewing the YouTube videos. The examples used in the videos and lab manual are discussed and shown in the textbook, improving GIS student understanding of essential remote sensing principles and technology while learning how to process and enhance images and DEMs using ArcGIS Pro. The lab manual, a page is shown in the upper right, and 12 YouTube videos are designed for GIS instructors, students, and users who want to do their own processing, enhancement, and information extraction of satellite and airborne images and DEMs using ArcGIS Pro. You can see the 12 exercises, the tutorials listed here. They cover a broad range of image processing tasks, algorithms, and help you find where these tasks are located on the various menus in ArcGIS Pro. The lab exercises require ArcGIS Spatial Analyst extension. Contact Ellis at ellis-geospatial.com for any questions or comments, and visit the publisher's website for more information and resources on the textbook. Lab 9 covers unsupervised classification. We'll be using the same Landsat scene that we used in Lab 8, the Afghanistan mountainous terrain. So we'll do a classification. We'll select a couple of the categories by SQL, just to demonstrate how SQL works. And then we'll generalize the map to get rid of the salt and pepper look. And then we'll convert it to a vector polygon shapefile. And we'll calculate the area. Then I'll combine the shapefile we made, our map, with a raster file, and then we'll see it in GoogleEarth. We'll be using the ISO cluster method, and that just clusters the pixels into natural groupings based on spectral characteristics and no direction from the analyst. We've got a 6-banded Landsat over here, a 457 total infrared color composite, and then a space shuttle DEM. So the first thing you want to do is make sure that statistics are calculated on the file you're going to work on, and just take the defaults. And there's our image, and we can tell that it's remember, we never changed our options, so the red is band 3 and the blue is band 2. And let's brighten it up. So we're looking at this mountainous terrain. These are cirque glaciers with snow and ice and debris covered ice here, and then downslope the valleys. We'll also bring in the 457. This is total infrared, so it's really quite dramatically different, and the lab manual goes into some extent on analyzing the different bands here. So there's two ways you can do it. One, you can go to this appearance and use the band combination and make a black and white band to look at called near IR or one of the SWIR 1. We want to make sure we want to highlight the 6-band image, use the stretch, and then say look at band 4. And you can see the snow is nice and white. We look at band 5. That's a SWIR band, shortwave infrared. Notice the difference. It's dramatic. So you can go into the lab manual and get a discussion as why do we see red glacier, ice and snow in the total IR. I'll brighten this again. We'll go to the geoprocessing window and we'll look up unsupervised classification. ISO cluster unsupervised. There's other ways to get to classification. Wizard. You can see supervised, unsupervised, object base. We're doing a spectral base, so we won't do this one. And then over in the raster functions, there's more classification tools. But we're going to stick with the ISO cluster. We pick our 6-band. We're going to do 5 classes. And we're not going to put it in the geodatabase. We'll put it here. The minimum size is 20, that's okay, but we want to sample every single pixel because it's such a small data set. And we'll just run it. And you can see it comes up with a random color scheme, but we've got our 5 classes, the yellow and the light blue up here. And then as we go down valley, we start to see 3, 2, 1. So I'll turn on the total IR, go to appearance, click on this, and we can compare which classes fit into what categories. So you can see the yellow and blue are capturing some pretty unique characteristics in the color IR, whereas the other 3 classes are downslope. So we'll stick with the 2 classes, 4 and 5, and extract those from this classification. So we'll open up the table. You can see our classes here, the value, and if I highlight those, you can see how they highlight up in the frame. Those classes that are picked are that light blue. Now we can just pick these 2, and we've selected those 2 classes and we can move forward, but I'm going to use the SQL tool to just demonstrate how it works. So we just want to extract the 4 and 5 class. So this is select by attributes. We've got our raster classification map here. It's a new selection. We click on expression, and what we want to say is where value is equal to 4, add another one, or the value is equal to 5. And that will extract those rows out. It's important to do for big data sets. And there they are. I'll just give this no color. And still and turn off our images. There, we've selected these. You can clearly see now what those 2 classes that were selected. If we zoom in, you'll see there's a lot of salt and pepper. I could turn off the world topographic map, but there's a lot of extra noise around. Small pixels, isolated pixels that we want to get rid of with the majority filter. So we go over to geoprocessing, type in majority. So you have to know the word that you're looking for to make this work. Our input raster will be the classification map, majority. It's only 2 classes. We use 8 pixels around each pixel we're analyzing, and now it's complete. And I'll color code them the same and come back to this. So I've colored the classes in our original and our majority filtered raster classification map. I'm going to clear the selection on this so you can see the pattern. We can zoom in. You see the little salt and pepper, and then if I turn on, you can see where it's disappeared. So I'll try the swipe tool, see if it makes it clearer. This is the before, and that's the after. It smooths it out to get rid of that salt and pepper look. Now I've got our raster classification map generalized, and now we want to go and convert that to a vector file. So again, raster to polygon. Our input raster will be the majority filter. It'll be the value. Well, we haven't displayed that yet, but there it is, the 2 classes. And this will be a shape file, so it's a glacier 2 class majority shape. And here's to simplify polygons. I don't recommend that because it degrades the map. So if you don't simplify, you'll see what we see in our raster map. And there we have, turn off the raster. This is now a shape file. We'll open up the attribute table, and now it has a grid code, and we'll work with that grid code next. Now what is interesting is I've done this previously with ArcGIS Pro, and I end up with 2 more columns, which are very, very efficient. I no longer get those when I process these raster maps into a shapefile. So I have to calculate the area myself. So let's go to the Symbology tab with our shapefile, and we'll pick those 2 unique values that are in the grid code. And once again, we can make the same color scheme. So I'll make the downslope brown. Doesn't have to be. It can be any color you want. And so we've got the same color code as we did with our raster. And over here in the label, we can call this one downslope ice debris. And what's nice is it shows up in our legend. It'll show up in our map that we make. And this is snow, ice. And it's over here in our legend now. So if we go ahead and make a map out of this and insert that, that'll be in the map itself. So when we did the digitizing, heads up digitizing, we had to create a new field. And I'm going to do that for the area. And you can see it at the bottom. I'll move this up. Area, the data type, we'll make it a float so it has a decimal point. And I'll keep this as numeric. It's a very extensive drop-down menu that you can use. I don't need to display so many decimal points. So I'll just do 3, and I'm going to do square kilometers in my analysis. So I have to save this. And when we go back to our map, there it is. And then I do calculate geometry. There's my shapefile, the area. And I want to calculate area of that. I'm going to try square kilometers. And my coordinate system will be the input raster map. And there it is in square kilometers. So I want to tally up how much area is in the downslope area and in the snow and ice area. And so I go summarize. The field would be the area field. It's a sum, and it's based on the grid code. And over here on the contents, I end up with a table that I can open. And there it is. So my sum area, I have 48 square kilometers in the downslope ice and debris area, the brown colored feature. And I have 32 square kilometers in snow and ice upslope. And this is the number of polygons in those 2 classes. We can't have anything selected when we want to export this. We want to export from ArcGIS into Excel. So I go to Data, export this little table we have. In my output location, I just make it the output folder, and the name I'll call it glacier area areas. It's opening up in my Microsoft is where I'll open it and bring it over. And so here's that table now that we can put out into a report with our area, and it's much easier to work in Microsoft. Do other tabulations, combine it with other data sets. So I'll close this. Now let's merge this map with a different raster data set. And so we'll bring over the Space Shuttle. Make sure everything else to get it all turned off. And got our Space Shuttle highlighted. Go to Symbology. Give it to min-max. That's not very useful. Let's do a hillshade on it. And so if we go back to hillshade, we do our space shuttle, make it come from 300. Let's have it a little lower than that, 35 degrees above the horizon. So we've got this nice hillshade. It's highlighted. Let's brighten it up a bit with there, that's a good looking scene. Now you can see that we've got our polygon on top. We can take this and fade it. You have to decide how much information you want. So 50%, is that clear enough? It's up to you to decide. I want to get rid of my swipe tool. I have to click this explore as far as I know. And then if we want to export this to GeoTIFF format so that we can put it into GoogleEarth, or that I'll do next, we want to fill our view with this scene as much as we can and cut out the white, and then we'll export this by, we've got just these two layers. It's a combined image. We go share, map, we're going to make a TIFF. I'm going to take all the other faults. It's got the GeoTIFF tags and the world files being written, so it'll easily go back into this GIS. So I'll bring it over. You can see in the contents on the left, there's our GeoTIFF. Now I'm going to bring it into GoogleEarth, import it into GoogleEarth. And now you can see I brought it into GoogleEarth. I can zoom in, bring it around, and we've added our interpretation of ice and snow and downslope debris into GoogleEarth. So our supervised classification map, not only do we have a new visualization of it, but we also have the statistics. We know it's 48 square kilometers downslope and about 32 square kilometers of snow and ice upslope. So with that, we complete our unsupervised classification map.